So the next example is going to be more complicated, because there are some aspects of the shape that we never dealt with in this example. So if you have any questions about this one, you better ask me now.
The only question I have is when you're computing it, on the test, you're going to show from the beginning of the limit.
Okay, so for the test, I would like you to show me everything until this line. So you begin with setting up coordinate system, interpreting that double integral as a limit, converting that limit into appropriate format, manipulating those delta x, delta y, recognizing the integrals, recognizing the function in your choice of coordinate system, because different people may choose different coordinate systems. Right? Then setting up the iterated integral, and then doing one step of iterated integration, because that is multivariable step. That is still not calculus 2. Well, it is very like calculus 2 procedure, but still you have to integrate with respect to one variable out of 2 or out of 3. 3 means when we do triple integral. Right? So I would like to see that you know that integrating with respect to x, you do something appropriate, and then substitute numbers for x, not for y. And once you do it once, you don't have to do it twice or 3 times. So for the test, you end up somewhere there. And if the expression is too complicated, because sometimes you make an error somewhere in the beginning, say in the setup of the function, the expression could be very long. If you don't want to proceed with several lines of substitutions, you just tell me what is it exactly that you are doing. That you are substituting these two numbers for x, and then you are subtracting the results. Okay. And as we look at other shapes of the region, there will be more work added in this intermediate setup. So don't worry about short solution or very short problem on test.
So it's like for the typical outline, how we do the generalization, strategy, and computation. This falls under computation. Or is it going to be mixed with both?
I wouldn't worry about generalization strategy for integration problems, because it's not easy to generalize the problem, right? So it doesn't make much sense to generalize. As far as strategy, well, you start with double integral, convert to iterated, proceed with two steps of, and that strategy will work for all the double or triple integrals. So there is no need to explain that to me. So you just go right ahead with how you set up, convert, compute. Okay. And it's the same story for the line integrals, for all the integrals we did last week. I don't need to see generalizations or strategy. Just go ahead and set up the integral. And once you get the formula for the integral for those problems, you stop there. Because in those integrals, you will end up with single integral, no multivariable stuff. So I'm not interested in your computation there. But here, I'm interested in one step.
So moving towards when you get the triple, you just want it to iterate with respect to like x and leave dy dz at the end.
Yes. Well, look, you had, remember we made a choice here of how to arrange additions, right? We counted by rows, and that effectively amounted to counting with respect to x curves. So if you switch your thinking and for some reason you choose to count by columns, well then it means you will count with respect to y, and that means you will have to integrate first with respect to y. So that choice you made in the beginning will affect all the computations, and you will have to stay with the choice you made in the beginning. You may not see the effect of changing that choice in this problem. But in the next problem, switching is not allowed at all. It won't even make sense at the end. So, if you want to switch, if you proceed with setup and you come up with something you don't like because of the order, you don't want to integrate with respect to x, but you would rather start with y, you have to forget about all these computations, about all these setups. You have to go back, change the order, and proceed again.
You can't just switch like the bounds?
No. No, you can for this problem, but this is very, very simple problem. And the next one, when we integrate over a triangle, you will see that you cannot. And it's not because because I'm hiding something very simple from you and making you to do some work, but it's conceptual thing that prevents you from figuring out what it should be at the end, unless you rework the whole procedure. And it will be even worse in 3D space when you do triple integral. And the shape you use in 3D is not as simple as the box, as if you have to integrate over some strange shape. The limits of integration will be arranged in a very special way according to what shape is, and counting one way or the other will result in totally different numbers. Well, we will see it immediately in the next example of a triangle.